can just move to the other analysis by drawing on the same data, because it will enable us to see actually what was already questioned here, how to deal with collocations and words in context. So this is this again. Let's move back here to the Google Collaboratory Jupyter Notebooks, and here is the case study number 2, word embeddings, Jesus saying. We will skip the CTA 3 for a moment. So again, I think that you should be able to run it on your own. Yes. So here I import the data. So what I have here is actually that here we focus only on the Gospel of John and Gospel of Thomas and Jesus' sayings within these 2 Gospels, in English, Greek, and later on also in Coptic. And we don't analyze, in this case, in this particular case, we do not analyze this on the level of a list of words, but on the level of cleaned list of sentences ascribed to Jesus. So here is the data set, and we can see it has the same format here. And once you have once you have the data in this form, you can do much more stuff with that, because you anymore do not have to rely only on individual words, but you can also ask which words appear together within a sentence, and that might produce very interesting results. What we did here is that we looked at words we were interested in how Gospel of Thomas and Gospel of John in their English translation, how they use specific terms. These terms are how they use begin, father, find, light, seek, understand, and word. We then replicated the same with the Coptic version and the Greek version. So we were interested with what terms these terms appear together in sentences. We can skip the Greek and Coptic for a moment. No, we cannot do this because the functions implement them as well at the same time. So we have to run all of this now. Should work in your case as well. And the Greek data. Yes, and here we define this. Here is the Coptic name. John is not defined. John is here. Okay. lines list is not here. Why is it possible? Mm-hmm. Yeah, because it's not problem here. Problem is this. I guess. Yes. Okay. So what's happening here? This is a complete LSA. And look at this. Yes. So this is a very crucial thing. Because this is a what is called word-to-word co-occurrence matrix. In this case, it's actually use this TF-IDF within it. I can perhaps run this one because it will be more straightforward. Yes, that's much more straightforward and easily interpretable. And actually, the number here indicates how often these two terms appear together within a text. So become and man appears 10 times within a sentence in the case of Jesus saying within the Gospel of Thomas. Become and one appears 5 times. Become and come 9 times, and so on and so on. This is absolutely crucial information because now you see actually what terms are related to each other. And most of the models which are nowadays here for analyzing large textual corpora rely on data in form like this word-to-word document word-to-word co-occurrence metrics. There are some variants, as we have seen here. You can put here not the number of the count. You can also calculate the TF-IDF, as we have seen in the previous exercise or in the previous case study, and put the value here instead. In this case, of this analysis, actually, there is one in this application. There is one specification that we do not analyze all words within the two Gospels, within the Gospel of John and Gospel of Thomas. We are instead interested only in terms which appear in both texts. Right? So this is not a complete word-to-word co-occurrence matrix, meaning that actually it would focus on this is strange. Why is it not alphabetical? Should be alphabetical. No, so it's not here. Vocabulary, yeah, because this parameter is off. Vocabulary, and we have vocabulary, vocabulary already from here. Words overlap. This, I don't know why is it not there. Perhaps I put it out for it's not our, what's the goal now? What we are searching for in this case study? Yeah, but it is in the model. It's not here, but it's later on used in this way. So the goal is that for each document you have this table, and in the next step, this table here in the function above is filtered for only for terms which appear in both gospels, in the gospel of Thomas and gospel of John. And having this, you can actually compare how the term father appears together with what terms it appears in the gospel of John, in comparison to with what terms it appears in the Gospel of Thomas, right? And getting an insight into that is actually very important information about meaning of a word, because now you see in what context the term is used. And once you have the data in this form, you can actually think about this as about a vector. As about a vector containing information about how this term is located in an x-dimensional space in respect to all other words in the corpus. I think it's now quite complicated, but this is the basic idea of word embeddings, which is getting more and more complex as the models are becoming more and more complex. But in this most simplest way, which is in the LSA model, for instance, it goes much farther. But here in the simplest version, you are just interested in the term father, for instance. And for the term father, you can look at this. Conc John. Other to list. Yeah. And make it on the level of this document only and Word. So here you see for these two words, you make a comparison of usage of the term father and of the term word within the Gospel of John. Because you see how much often the term father appear with any of the words in this rows in this table. This is our table. And from this table, we extract this column and this column. And having this data, we can make a comparison of this column with this column. And in terms of word embeddings, you can think about this list of numbers, a vector consisting of information about location in a x-dimensional space. The number of dimension is defined by this length of the list, the length of this list. So you should imagine a space of having 284 dimensions, and for each dimension, you can compare actually whether the word father is used in a similar way as the word as the second word, as the word board, so to say. Is it important? Is it understandable? Yes, perfect. So the only problem with that, no, not the only problem, but the one problem with that is once you make a comparison because now you can run a correlation between these two rows, between these two lists of words, a list of numbers, right? And two words which appear in the same sentences should with not in the same sentences, which appear together with the same words should have a higher correlation in general. But the problem is that in this you have a lot of zeros, and these zeros disrupt this correlation. Yeah, because if you have zero between these two numbers, that means that's very similar. So the thing is that you have to somehow to overcome this. There is procedure which has been developed by some linguists associated with Latin semantic analysis. They developed what is called singular value decomposition, SVD. And what this SVD is doing is actually that it approaches this number of these dimensions, and it's actually somehow condense these dimensions into a much smaller amount of dimensions. So you have a location for each word in a space which has 284 dimensions. But this application of this procedure, of this algorithm, enable you to reduce this dimensionality into, for instance, 100 dimensions. And by this reduction, you will actually eliminate all this false positive of the similarity in terms of zeros. And it's actually involved already here, SVD, truncated SVD, number of components. And in this case of the documents above, we reduce the dimensions from 284 to only 25 dimensions. And this is actually what is in this table. In this table, you have the same words as columns, right? But for now, there is the rows do not correspond to the terms itself, but has been somehow merged together according to this algorithm, that now you have the data just in 25 dimensions. And now once you have them in 25 dimensions, you can make a reliable comparison between any two words, how they are close to each other in terms of in what context they are used in the documents, in together with what words. And this is on a very general level, this is a very basic idea behind word embeddings. Word embeddings is a very general term, which is used very commonly nowadays in computational linguistic or natural language processing literature. And this is the simplest version of it, so to say. The more complicated things do not work only by word co-occurrences, but also work with word by document co-occurrences, and then reduce the word by document co-occurrences, actually. But for doing this, you need much larger data set than this. And remember that I mentioned that I am interested here only in words which are in both Gospels, both in the Gospel of John and Gospel of Thomas. Why? Because having this, yeah, here is the same for the Greek version, for the Coptic version, Coptic text. Because now you can find algorithms for getting terms which are most similar to each term in terms of the location of this 25-dimensional space. And this is what is called, this is a common example of nearest neighbors analysis, that you take any of the term, like here we have the input term father, and for it we look for its most common terms in this model in terms how these two columns are similar. Yeah, there is some cosine similarity of the two vectors. It's behind that. And because we have the same terms in both Gospels, in the Gospel of John and the Gospel of Thomas, and having high overlap, what we can actually do is here are the 6 terms in the Gospel of John we are interested in, and here are how they are related to 123 terms which are in both Gospels. And this is the important thing we report in our article, that we simply measure a correlation. We simply measure a correlation between symptom difference will be fine. Yeah, because I haven't run the previous code. No, that does not make sense at this moment. So what we do here is that we look at the term at the key term we were interested in. Why these terms? These 6 terms are often mentioned in the literature concerning the relationship between the Gospel of Thomas and the Gospel of John, for which some scholars say, look at the term begin or beginning. This is a term which indicates that the Gospel of Thomas and Gospel of John are related, because both of them speak a lot about begin and beginning. Or look at the term Father, find, light, seek, word. That some scholars suggest they have very similar topics on which they focus. So to look at this in more detail, what we did, we looked at the 10 nearest neighbors to these terms according to this measurement I showed above. Right? What are the terms which are most closely, which have the most similar vector as these terms? By this, we can get some context of usage of these terms. They get some understanding of in what context these terms are used, and compare it against each other qualitatively, interpretatively. But we can also evaluate it quantitatively in terms of correlation. And here we actually see that the term begin, at least according to this methodology, is used quite differently between the two Gospels in respect to other terms with which it appears over the sentences. In the case of Father, the correlation is slightly higher. In the case of find, it's even higher. And here it's lower in light. Here is quite bigger. And again, here is quite bigger. So it's not so easy how to exactly to interpret these results, but at least they indicate that the term word, yes, it's more similarly used between these two Gospels than, for instance, the term begin, which is used differently. The problem here is that we work here with English translation and very small amount of text. Once the two documents would be much bigger, we could apply much more advanced measurements. We could use different type of models. We could use, for instance, the latent semantic analysis I mentioned already. Perhaps we could even use the word-to-vec algorithms, which has been developed by Tomáš Mikolov. But with this limited amount of text, it's impossible. And second, perhaps even bigger problem here is that we rely on English translation. We cannot do otherwise because, yes, there is some Coptic version of the Gospel of John, but there is not a reliable version, Greek version of the Gospel of Thomas. So we cannot proceed so far with that. But we still hope that this is somehow informative, and the employment of these models for comparing usage of particular terms across documents is the way to go. It's the way to go because it does not. It's not based only on vocabulary. It's based on context of usage, and yeah, there is an endless amount of different versions of these algorithms, but the basic idea is the same. You compare the co-occurrences of terms and co-occurrences of terms in respect to documents, and you have to learn to think about terms as vectors, informing us about position of particular word in a multidimensional space, and then you can compare position of different terms in this multidimensional space and identify terms which are closer to each other in comparison to terms which are more distant from each other. And the last important concept is the dimension reduction, that you can, from a space which has 200, 300, or 10,000 dimensions, you can reduce the dimensions into something what is more comparable once you have just 200 dimensions. But there is a lot of debate about actually what should be, what is the appropriate number of dimensions for making this comparison in the case of particle word embedding models.